Okay, this question has a table of values and a quadratic equation. What we need to do is fill out the table of values for the y values for various x values, and then plot those points on a graph down here as well, and just answer a few questions. Okay, so first of all, filling out the table of values, we have to be careful with our negative x values when we're substituting those values into the equation. So for example, with x equals -5, our y value, we've got to be careful that we do substitute in the -5 correctly. So in here it'll be -2, the -5 is going to go where that x is. It's -2 times -5 squared. So notice the x I've replaced with a -5 in brackets, and then we're taking away 6 times, again, the x value here is -5. So then let's work that out. We've got -5 squared, which is +25, because it's -5 times -5. Negative times a negative gives a positive. And then we're multiplying that by -2. So we get -2 times +25, which is -50. And here we've got a -6 times a -5, which gives a +30, to give us an answer there of -20. And we can put that into our table of values. Similar for our -4, again, just being careful with those negative x values. We'll get y is equal to 2 times -4 squared. Take 6 times -4. The -4 squared, or -4 all squared, will be +16. Times by that -2 will give -32. And the -6 times the -4 gives a +24. To give us our answer there of -8, which we can put into our table. Okay, let's do these other ones in our head. So -3 all squared is +9 times -2 is -18. And then it's -18 take away 6 times a -3. In other words, we're adding 18 onto -18. That'll give us 0. -2, we'll get -2 all squared. It's -2 times -2 is 4, +4, times -2 is -8. And for this one, we've got -6 times -2, which is +12. So effectively, we've got -8 plus 12, which is +4. The -1, we'll get -1 all squared is +1. -2 times +1 is -2. And then we're adding 6, we'll get 4 again. 0 is an easy one. When we substitute 0 in here, we get -2 times 0. Take 6 times 0, we'll just get 0. And at this stage here, we're seeing our quadratic pattern: -20, -8, 0, 4, 4, 0. So we're pretty confident that our pattern will continue there to give us -8 and -20. Okay, so really it's just a matter of making sure you're really careful with those negative numbers. And you know what you can do if you're having trouble with that is you could do these calculations on your calculator. But you would put into your calculator, making sure you're putting the brackets in here, so the -5 does get squared. Okay, so plotting these points, let's do that. So we've got -5, -20. Now that's going to be off our graph completely, because it only goes down to -8. So let's go to the next point, which is our -4, -8. So there's -4 in the x direction. We're going to go all the way down to -8. There's our point there. Next point from the table was -3, 0, which is there. Then we've got -2, +4. X is -1, y is +4. 0, 0, so it cuts the y-axis at the origin. And then we have +1, -8, and that's as far as we'll go in our graph. So from there we can draw a nice smooth parabola for those points. Often the hardest part, just getting a freehand drawing a nice smooth parabola can be quite tricky. Now you notice when we get to these top 2 points here, they're both at the same y value. So what's really happening here is the graph goes a little bit further up and then starts coming back down. So it looks something like that. There's our sketch of our parabola. Okay, and I might just label that y is equal to -2x squared take 6x. Okay, a few other questions we've got on this one. We've got coordinates of the turning point. Now the turning point's up here. Now the problem with this is that we can kind of see with symmetry that the x value of the turning point will be halfway between -2 and -1. In other words, that x is equal to -1.5, but we don't actually know what the y value is from the graph. We could guess it. I might guess at about perhaps 4.3, but we really need to work that out a bit more accurately. And what we can do is just substitute that x value of -1.5 into our equation here. Now, because I've got a decimal, I might do that on my calculator. And here it is here. Now you notice when I've input that into my calculator, I've put the -1.5 in brackets where the x should be on our equation. Let's put that up a little bit. So you can see in our equation here the x value of -1.5. I've actually put that into brackets here. And we'll just press execute on that, and our answer there comes out to exactly 4.5. Okay, so there's our coordinates. And we can see perhaps from my graph here, I've drawn it probably a little bit flat through there. Should have gone a little bit higher up to about there. Okay, does the parabola have a maximum or minimum? Well, clearly this is a maximum turning point. You're getting a maximum point at the turning point of the parabola. So that would be max. The equation of the line of symmetry. Now the line of symmetry is the straight line which divides that parabola exactly in half. You know, if you like, the parabola would reflect about itself over that line. Now, when we're giving the line of symmetry, we always need to give it as an equation. So we say it's x is equal to -1.5 in this case. So your equation of your line of symmetry will always be x is equal to whatever x value that line takes. In this case, it's going through at -1.5 here. And finally, coordinates of the y-intercept. That's an easy one. It's just where it crosses the y-axis, and we can see here it crosses at an x value of 0, y value of 0. There's our answer.